What's that? It's Mr. Mullins doing some chemistry. So today we are going to be talking about the metric system. Hopefully you remember some stuff about the metric system from your science class or your biology class or some kind of science class that you've taken in the past. As you may know, America typically does not use the metric system except in science. We are stuck on the standard system. You may know units like gallons or inches, things like that. But in science, we are going to be using the metric system solely. It is important that you become familiar with it and you learn how to convert between the units of the metric system without just swinging the decimal. So let's take a look at the metric system. You know that a saying probably from some previous classes, King Henry died by drinking chocolate milk. This is a great saying to help you remember the order. But as you know, each one of these little letters here stand for something. The K stands for kilo, the H stands for hecta, deca, base, deci, centi, and milli. So each one of these means something and you need to know what the prefix is. Kilo also, well, all of them have a numerical value, but kilo has a numerical value of 1,000. Hecta is 10. Deca is 10, hecta is 100, deca is 10, just like a decade. Base is 0, or the ones place. Deci is a tenth. Centi is 100th, and you guessed it, milli is 1,000th. So you notice that kilo has the largest units or the largest numerical value, and they get smaller as we go over here to milli. The understanding of that and these numerical values could help you, say, on a multiple choice test where you are trying to cancel out answers. So in the past, when you may have been doing some metric conversions, you may have been asked to do something like this: 12 meters, convert it to kilometers. And immediately what you would do is you would find your decimal place and you would start to move it to one direction or the other. Well, in chemistry, we rely more on a mathematical approach that we call dimensional analysis. So that's what we're going to be doing today. I'm going to teach you to do dimensional analysis to convert between one unit and the other. The reason that we do this is because oftentimes we run into units like moles that are not related to the metric system at all. They're not on our King Henry died by drinking chocolate milk. But we still need to know how to get from moles to, say, atoms. These two different units are related, or we may need to get from moles to liters, which, as again, you see, moles is not on the metric system, and we still need to be able to convert. You can do this using dimensional analysis. Dimensional analysis is a series of fractions that show the relationships between different units. We call those relationships conversion factors. Conversion factors can be memorized, like 1 inch is equal to 2.54 centimeters, something you should already know. Or maybe an easier one, 1 dozen is equal to 12 eggs. Or how about 1 foot is equal to 12 inches? You should know all of these conversion factors that show you the relationship between two different units. Now, lucky for you, you are able to learn all of the conversion factors using your simple metric mnemonic, King Henry died by drinking chocolate milk. So let's go ahead and get started on a problem. Let's say that you are asked to do 2.54 centimeters and they want you to convert that to, say, meters. We'll start with a simple one. The way that we do this, the first step we always do is take the number that is given to us and we can make it into a fraction. If we want to make this into a fraction, simply all we have to do is put a 1 under it. There is our fraction for 2.54 centimeters. We are going to create another fraction that we call a conversion factor that is going to help us cancel out our centimeter unit and convert it to the meter unit. Now there's two ways to do this. You can either have these conversion factors memorized, or we can come back to our handy saying, King Henry died by drinking chocolate milk, and I'll show you where that comes into play in just 1 second. So in math, when we are trying to get rid of a variable, say we have a variable x on top of a fraction, and we want to get rid of it, you have probably learned that if you put it on one on the bottom, they can cancel each other out. The same is true with units. Here in this fraction, we have centimeters on the top of the fraction. We are going to create another fraction with centimeters on the bottom so that we can cancel our centimeter units out, because we want to be left with meters, not centimeters. Since we want to be left with meters, we are going to put that on the top of this fraction. Now you have to know, what is the relationship between centimeters and meters? Does anybody know? Probably not. You may know that 1 meter is equal to 100 centimeters. You might be familiar with the meter stick that you use in class. But if you are not, I'm going to show you a way using this over here to help you know that. The first question I always ask my students is, which one of these is larger? Is it meter or is it centimeter? They often say, hey, it's the meter. That's correct. Remember that the meter falls under the base unit. So we are going to take a 1 and put it with our meter. We're also going to put a 1 down here at the base unit. See, I put it right below it. The next thing we're going to do is put a 0 where centi is. So we say, oh, here's centi, so let me put a 0 with it. All we have to do now is simply fill in zeros, and we see that we have 100 centimeters is equal to that 1 meter we started with, just like I had memorized. So I take this conversion factor and I plug it into my fraction problem right here. 1 meter is equal to 100 centimeters. The next step that we do is a simple math problem. We know that when fractions are being multiplied by each other, all we have to do is multiply straight across and divide anything that's on the bottom. So in this case, I would do 2.54 multiplied by 1 divided by 100. And if you get out your calculator and you do this, we get 2.54 divided by 100 gives me 0.0254. Lots of people just stop right here and say, oh, I'm done. But we know that in chemistry, we are not allowed to leave any naked numbers. In this case, 0.0254 is a naked number because it does not have a unit. We must go back to our dimensional analysis problem and see what units are left. Because centimeters is on the top of this fraction and the bottom of this fraction, they are canceled out. We are left with the meters unit, which is exactly what we wanted to be left with. Now I know that gets a little messy when we're first learning to do it, but it will get easier on our next problem. Let's go ahead and try one. Alright, so let's say that someone asks us to convert something else. Let's go with 13 kilometers is equal to how many centimeters? And they want us to know, hey, we got 13 kilometers. It's going to be a lot of centimeters. As you know, centimeters is much smaller than kilometers. So the first thing we're going to do is we are going to turn our 13 kilometers into a fraction. Hopefully this is starting to come a little easier to you. All we have to do is write 13 kilometers over 1, turning it into a fraction. The next thing we need to do is determine what our conversion factor is. What are we going to do to get rid of this kilometer and get to the centimeters that we need? Well, you're probably thinking it. Kilometers is on the top of this fraction. We need to put it on the bottom of our conversion factor so that they will cancel out. We want to go from kilometers to centimeters, so we are going to put centimeters on the top. Now we need to figure out the numbers that go within our conversion factor. What is the relationship between centimeters and kilometers? Maybe you already know. Maybe you have it memorized. If you do, that's great. If not, let's go back to our King Henry died by drinking chocolate milk to help us out. Which one of these is larger? Which unit? The kilometer unit or the centimeter unit? Hopefully you're thinking that the kilometer unit is larger, so we're going to use kilometer as 1. We're going to say for every 1 kilometer, I'm going to find out how many centimeters there are. So over here under kilo, we're going to put our 1. We're going to put a 0 under centi, which is C, and we're going to fill out zeros until we get back over to kilo. So in this case, it looks like there are 100,000 centimeters in 1 kilometer. Now this turns into a simple math problem. We see that our kilometers are going to cancel each other out because one unit is on the top of a fraction and 1 unit is on the bottom of a fraction. That's going to leave our answer with a unit of centimeters. So in your calculator, let's do our math. 13 multiplied by 100,000 divided by 1 times 1, which is, 1. So 13 times 100,000, as you know, will give us 1,300,000. Notice how my answer has a number and a unit. The unit is exactly what they ask us for. Our kilometers are now gone because they canceled each other out. Let's go ahead and do another problem. In this problem, we are going to be starting with 0.013 decaliters, and we are going to convert that to hectoliters. So, again, we are going to start with the number that they gave us, and we are going to turn it into a fraction. So we've got 0.13 decaliters turned into a fraction. I'm going to draw my dimensional analysis table just a little different this time, so that you can get used to seeing it many ways. As you can see, my fraction is still there. I'm just going to be drawing it in a table instead of in a fraction. We now want to figure out what is our relationship between decaliters and hectoliters. Maybe you're thinking, oh, King Henry died by drinking chocolate milk. Hopefully that's what you were thinking, and you see that deca and hecta are both found on the metric scale, even though we're not used to them. So we can indeed use this to convert between the two of them. In order to get rid of our decaliter unit, where do we need to put it? On the bottom of the next fraction. That's right. So we're going to put it down here on the bottom of this fraction, and we are trying to convert to hectoliters. You can see again, this is a fraction. I normally don't draw the parentheses when I draw it in the table, but I'm drawing them now just so you can see that it's there. Ask yourself, which one of these units are larger? Is it the hectoliter or is it the decaliter? What is the relationship between decaliters and hectoliters? Does anyone know? Obviously, the hectoliters is larger, so we're going to put our 1 under hectoliter, fill out zeros over to decaliters. Now remember that first D is decaliters. The second D would be deciliters, which a lot of people make the mistake. So that's right, there are 10 decaliters in 1 hectoliter. You can see our conversion factor is just plugged in fraction form. Now that we have our conversion factor, we can do our math. We see that there's a decaliter unit on the bottom, a decaliter unit on top. We're canceling it out just like we want it to, and look what we're left with, hectoliters. Hectoliters. All that's left to do is a little bit of math, which involves your calculator. We are going to do 0.013 multiplied by 1, divided by 1, divided by 10. So obviously we know we don't need to do this one step. We can just go straight to 0.013 divided by 10. If you plug that in your calculator, you're going to get an even smaller number, 0.0013 hectoliter. Hopefully you're starting to recognize that all of my answers are going to have a number and a unit every single time. And the unit that I have here is the unit I was left with here. So it's always going to be that way. Let's do one more problem. Alright, so this time I'm going to give you a few minutes to try to do one of these problems on your own. Let's go ahead and start with 3,894 milliliters, and we are going to convert that to, let's go to hectoliters again. So pause the video now and try to solve this problem on your own. In this situation, we're going to start the same way that we always do. If you've not had time to finish, pause the video again. We are going to turn the number that we start with into a fraction. In this case, all we have to do is put the 1 under it. I'm going to do this dimensional analysis table again, because that's the way I like to do it. Miss Spivey shows it other ways. If I want to get rid of the milliliter unit, I need to put it on the bottom of my next fraction so that the units will cancel. And we obviously see here that we want to go to hectoliters. You have to ask yourself, do you know the relationship between milliliters and hectoliters? If you know it off the top of your head, great. If you don't, let's go back to the King Henry died by drinking chocolate milk in order to figure it out. Now we want to know, what is this relationship? One way to do it is by thinking which one of these units is larger. Is it the hectoliter unit or is it the milliliter unit? You're probably learning that all the units to the left are always larger. So again, this time hectoliter will be the largest. We're putting a 1 right below our hectoliter. Next, we're going to put our 0 under milliliter, and we're going to fill zeros out for every unit until we get over to hecta. So in this case, it looks like there are 100,000 milliliters in 1 hectoliter. You notice how we're going to plug our conversion factor directly in fraction form. Conversion factor, conversion fraction. So now that we have these, we can start to do our math, which has become the easiest part, I hope. The milliliter units are going to cancel because one is on top, one is on bottom, and we are left with exactly what we want in hectoliters. Let's go ahead and do our problem. We've got 3,894. We are going to divide by 100,000 because it is on the bottom of our fraction, which gives us 0.03894. There is our answer. Again, we have a number and we have a unit. No naked units out there, folks. Always put a unit with your number.